Good evening. All right, so today we're looking at factors. But before we look at factors, we're starting off by or with a little understanding of the coordinates and points. Right? So just to recap, when we're looking at our graph, we have the x-axis, which I'm going to retrace. That's the one that lays down. That's the horizontal line. And then you have your y-axis, which is the one that stands up, or it's the one that is vertical. Although your y-axis is standing up or vertical, your y values are actually horizontal, right? So this here is the line y is equal to 1. This here is the line y is equal to 2, y is equal to 3. Below here will be y is equal to -1. So with that being said, that means your x-axis is actually where y is equal to 0. Right? So your x-axis is actually where y is equal to 0. Then for your x values, although the x-axis is horizontal, your x values are vertical. So this will be x is 1, x is 2, x is 3, x is 4, x is -1 will be on this side, which means that your y-axis is actually where x is equal to 0. Now, in order to read the coordinates of your point, you always want to put the x value or the x coordinate first, and then the y coordinate. And they're separated by a comma in brackets. So for example, the A. The x, you're reading the x first. So x is 1 and y is also 1. So the coordinates of A will be 1, 1. Look at B. B, the coordinates of B, x is 2 and y is 3. So we'll write it as 2, 3. Look at C. X is 4 and y is 2. So we write that as 4, 2. Now, think of your coordinates as the location or the address or the position of that point. So C is located at 4, 2. So it's telling me where it resides, where it is, where it's positioned, however you want to think about it. But let's think of it as your address. So let's say this is the address where you live. The vector can be written as a column vector, right? Meaning where we put the x and the y in the form of a column. When it is in this position, the vector gives us instructions how to get from one point to another, right? So for the vector, think of it as the instructions. right? So you're thinking of it as the instructions to get to the point. So the number on top, X, will tell me whether to move left. If X is a negative number, it means that it's going to be moving that number of times to the left. But if X is a positive number, it means that it's moving that amount of numbers or places to the right. Your bottom number, the Y, tells you up or down. If Y is a positive number, it's telling you that number of places up. And if it is that it's a negative number, it's telling you that amount of places down. Now, a position vector, right, that we must note. When you see the term position vector, a position vector is always the instructions from the origin to wherever the point is, right? So think of your position vector as the instructions right? So it's the instructions from the origin right? So we call it O. Basically, that is this point here, where it crosses the y-axis, crosses the x-axis. So we call that the origin. So it's the instructions from the origin to the point. So let's say they asked you, what is the position vector of A? Now, the position vector always gives the instruction from the origin. So it's basically, you're telling me, you are giving me the instructions from O to A. And it's written like this, right? So this here would be the position vector of A. Right? So basically, the first letter in your vector tells you where you're starting. And the second letter tells you where you're going to end up. Right? Because we're trying to build a story from this. So from O, the origin, which is here, I'm circling it so you look where I'm looking. In order to get to A, I'm going to move one place to the right and one place up, which is where A is located, right? So in order to write the position vector of OA, we're moving one place to the right. So where X is, we'll put 1. And we're moving one place up. So we're going to put 1 to the bottom. Now, the position vector is going to correspond with the same values of X and Y as the points. So point A will be 1, 1. But the position vector which is the instructions from O to A, will be written as this, where it's telling you how you're moving to get to the point. All right, so I'm going to do another one, but this time with B. Right, so just taking a look at B now. Now, B is situated at this location. It is located at where X is 2 and Y is 3. So it's written like this. This is the address. Now, if they asked you, write point B as a position vector. As a position vector, it means that you're going to give me the instructions starting from O to B, right? And you write it like this. It basically shows where you're starting. You're starting from O and you're finishing at B, point B. So in order to write it as a position vector, you're going to put it as a column. Now, in order for me to start from O, which was here, I had to move 1, 2 places to the right, and then 1, 2, 3 places up, right? So X tells me how many times we had to move to the right or left. We move to the right, which means it's going to be positive 2. And we had to move up, so the Y value of the vector will be 3. We had to move 3 places up. So as a position vector, OB will be 2, 3. So just to remind you, B in the form of 2, 3, like this, that's the location, that's the address. OB in the form like this, that's the instructions. Think of it as Waze or your Google Maps. When you put in your point where you're starting, so let's say starting from Citygate and you're ending in Diego Martin, it's going to tell you what is the instructions to get from that point to the other point. All right, so with that being said, let's see some different paths we could take. So let's say you want to get from B to C, right? So you want to move from B to C. Now, it comes like you're asking, what is the instructions from B to C? Right, so let's say you want to get the instructions from B to C. That means you want to start from B and end at C. Right, so the first letter, when it's written like this, it's telling me where you're starting from and where you're going. So that simply means it gives you the direction, right? Because remember, a vector tells you the direction as well as the magnitude, meaning how much to move. So it's telling me I want to move from B to C. So these arrows show the direction in which you're moving. Now let's pretend I am at point B. And you are at point C. So I asking you how to get to where you are. So you're giving me instructions. And for nothing in the world, I could understand how to get from my house to your house, right? So B meaning my house and C being your house. I don't understand the instructions. So you decide, all right, miss, you know where the bus route is? And I'm like, yeah, I know the bus route. Now think of the bus route as a point that connects the start and the finish. You usually look for it in the form of a triangle. Right? So it look for like a triangle where it's connected to a point that you know both routes for. Right? So you're looking for a route that you know. So you tell me, miss, you know the bus route? And I'm like, yeah, I know the bus route. So let's pretend O is the bus route. I'll put it as PBR, the priority bus route. Right? So you're like, all right, miss. From your house, right? So it's like you're breaking it down easy squeezy for me. Miss, when you leave your house, you will walk so, and so in order to get to the bus route, right? Now, the so would be, I'm walking from my house, which is B, and I'm walking towards the bus route, which is O, right? So I'm going to start from my house, B, and I'll go to the bus route, which is O. All right, I reach the bus route. So you tell me, all right, miss, when you reach the bus route, you're going to walk so, and so, and you'll see my house. So this is how that instruction is written. If they give you a vector to find, you find a common point that connects the start and the end point. So it's like a location that you know information of. Right, so I know the bus route, so I'll walk from my house to the bus route. And then from the bus route, you'll give me the instructions how to get to your house. And then when I reach your house, it's like I went the long way around. And it's like, oh, shucks. You know, I could have just right there. I could have just walked there. I said right instead of walk. I could have just walked there. My house right there. Right? So it's like you're going to take the long way around in order to find the shortcut. All right. So from B to O. Now remember, we know that, and I'm writing in black above. No, I'm writing on black here. Right? So we know that my house, remember I live at B. My house has the address of 2, 3. Right? Remember, we found that before. Sometimes they might give you it like this, or they might give you it as a graph, and you have to find the location or the position, which is the point. Right? So my house is situated at point B. So my address is 2, 3. Now, from the bus route to my house, right? So the instructions to get from the bus route to my house would be in this form. Right? Remember, I'm moving 2 places right and 3 places up. So to be written like this. But in order for me to walk from my house to the bus route, that's the opposite direction. That's the opposite direction I'm walking. So in order, if it is that you have vectors in opposite directions, we have to change the sign. Right? So to show the opposite direction, we change the sign. Right? So basically, the positive or the negative, remember here, tells us the direction we're moving in. Right? Because remember, if it's a negative number, for the X, you're moving left. But if it is that you have to move in the opposite direction, meaning to the right, you change the sign. Right? So if I want to show that I'm not moving from O to B, but instead from B to O, I'll change the sign. So this will become negative of 2, 3. So therefore, this comes like -1 outside. Right? So if you just have the negative sign, it's understood to be -1. And remember, anytime you have a number outside, we multiply it by everything inside. So that comes like saying -1 by 2 will be -2. And -1 by 3, which is -3. So because I'm moving from B to O, I'm changing the direction. So I change the sign of my vector. So I'm moving from my house to the bus street. And then I'll walk from the bus route to C. Now remember, I'm writing in purple here now. The location of C, which is your house, is at 4, 2. Now we know that we could get the instructions from O to C because all we do is we just write this as a column. Now we're moving in the same direction from O to C. So it will remain the same. The only reason why we change the sign is because remember, I'm reversing. I'm moving from my house to the bus route, which is the opposite direction. All right. So we know the instructions, right? So this is like our ways. It's telling me how to get from B to O and then from O to C. You know how Waze and Google Maps tells us in 4 kilometers, turn right, right? That is like what this is doing. It's telling you how to move. Now, in vectors, we could add vectors, but add and subtract vectors. But when you do it, you can add the x's and you can add the y's, right? So you always add or subtract the corresponding elements. So in order to find out what is BC, we're going to add so we have -4 plus 2. When you have two, say, different signs, we subtract and keep the sign of the bigger. So -2 plus 4, you're going to subtract like normal. And because the 4 is bigger and it's positive, we keep it. So it's going to be +2. And then you're going to do the same for the y's. So you have -3 plus 2. Anytime you have numbers with two different signs, so remember the sign is always carried in front. So once you have two different signs, the rule is you subtract like normal. So 3 take away 2 is 1. And you keep the sign that is in front of the bigger of the two, which is negative. So it will be -1. So when we add this, it gives us the instructions from B to C. So when I reach by you now, I'm like, shucks, you know how easy that is. All I had to do, because remember the top number here is telling me, because it's positive, it's telling me to move 2 places right. And the bottom here, because it's negative, it's telling me to move 1 place down. So from my house, I just have to move 2 places to the right, 1, 2, and 1 place down, 1, to get to your house. So it's like you gave me the long way around in order to find the shortcuts. All right, so sometimes they may give us questions whereby they might ask us to find the vector. They may give you a graph. If they give you it as a graph, all you have to do is to get the points, to write the points. But sometimes they may give you it like this, or they may give you it like this. All right, so they may give you it like this, which is as the vector, or they may give you it like this, which is as the position or the coordinates. All right, So let's break this up and make sure that we understand it. So they said the position vectors of points R, S, and T relative to the origin. Right? So all that is telling us is that our point R would be written like this. Not because they gave me it here, right? But the position would be like this. But they gave you the position vector, which means it's coming from the origin to that position. And they gave you it as -3, 4. Right? So from this, it says the position vector of the points R, S, and T relative to an origin O, R, and you notice they listed them out and they said respectively. That simply means the order in which they listed them here, it is going to correspond. So the second one, S, would be the second one here. So that means the position vector of S OS would be 1, 1. Right? So they gave it to us. And the third one, T, they gave us it as 5, -2. So the position of T is actually 5, -2. Right? So if I write it like these as the coordinates, those are the positions, the location, the address. But when I write it like this, from the origin to the point, this is like the instructions as to how to get it. Right? So the first part, they said, express in the form XY the vectors RS and ST. Right. So let's take a look at the first one, which is RS. Oh my gosh. I'm trying to get from R to S. Now you don't have to draw it, huh? It's just no matter what they give you, it's the same narrative. It's the same story we're going to use. Right? So sometimes they might give you it with the diagram, and sometimes they might not give you it with the diagram. But it's the same narrative, it's the same story. I'm trying to get from R to S. But if it's from the position vector, it means that I know the origin. Right? So anytime they're mentioning about the position vector, or if you bring the position vector into it, it means that the origin is involved. So it's like, I don't understand how to get from R to S. All right. You know the bus routes. Your bus route is going to be a common position that both of you know. Yes, I know the bus route well. All right. So you're going to walk so from your house to the bus route. Right? So it's like you're going away. You're going the longer way around. So you'll move from R to O, and then from O to S. Right? So we're going to move from R, which is my starting point, right? Because remember, I'm starting at R. So I'm going to move from R to O. And then in mathematics, we add on the other part from O to S. Right, so you look it up on Waze. All right, so from the bus route to my house R, does this. Right, because remember, we know the instructions from the bus route to my house. So we simply have to change the direction, right? Because if we know OR, then RO, we're going to change the direction of OR. So it will be the negative of -3, 4. And then I know the instructions from O to S, and I'm moving in the same direction from O to S. So that will stay the same. So this negative sign means that I'm going to change each of these inside of here. So basically, you just change the sign. But if you want to know like the how and the why, the negative will be like -1 by -3. When you multiply like normal, but once you have two same signs, your answer is positive. When we have two different signs, right, as the -1 by the +4, multiply like normal, but you'll have a negative answer, right? So the change in direction from R to O would be 3, -4. So basically change the sign. And then we're going to add on OS, which was 1, 1. So remember, when you're adding or subtracting vectors, you add the corresponding elements or the ones in the same position. So 3 plus 1 is 4. -4 plus 1, that will be -3. So my answer, which will be the instructions from R to S, would be 4, -3. Pause in here.